All right, so this is problem 12.8. It's on page 515. And I'll read it to you first. It says, a truck is proceeding up a long 2.5% grade at a constant speed of 45 miles per hour. If the driver does not change the throttle setting or shift gears at the top of the hill, what will be the acceleration of the truck as it starts moving on the level section of road? Okay, so let's draw a picture quickly. Draw the truck. And consider what's going on. So at this 2.5% grade, well, what does 2.5% grade mean? Well, what that means is that the rise is 2.5% of the run. So X. Another way of writing this is that Y equals 0.025, let's see, 1, 2, yeah, times X. Okay, that's another way of writing that 2.5% grade. Okay. Now he's proceeding up the incline at a speed of 45 miles per hour. So his velocity is 45 miles per hour. Now I need some calculator help. Let's just convert this to feet per second. So we'd like to deal with feet per second instead. So 45 miles an hour, how many feet in a mile? 5280, that's right. 5280 feet per mile. How about seconds in an hour? 3,600, that's right. 1 hour is 3,600 seconds. Be careful. I've had very good students before try to put 1 hour 60 seconds because they just didn't stop and think about the simple stuff. Okay, so be careful about that. Anyway, so hours go away. We'll have feet per second. So what speed are we moving up this hill?
66 meters per second.
66 meters. You mean feet?
Yeah.
Okay, feet per second. Don't worry, I do the same thing. So 66 feet per second is the speed up the incline. Now, if we look at this, what does that mean? Well, this is chapter 12, so what do we always have to do in chapter 12?
Three-body diagram.
Three-body diagram, that's right. Good job. So here's the truck. The truck is being pulled up. Now, how is the truck being pulled up? Well, essentially, there's friction on the road, right? That friction is what causes the truck to move upward. Well, what other forces are there? There's the weight of the truck, and there's the normal force. Okay? Those are the three forces that are acting on this particle, essentially. Okay? Which direction are we interested in? Well, I'm interested in this direction. So I'm going to put a coordinate system like this initially, y and x here, and I'm only going to analyze the x direction because I'm really interested in this frictional force. In other words, how much force can the truck's engine develop? That's what I'm really interested in here. Because once we get to level ground, it should be generating the same force, and that will help me determine the acceleration of the truck. All right. So I need to calculate this frictional force. How would I do that? Well, apparently the sum of forces in the x direction is equal to what?
0.
0, that's right, because the truck's not accelerating. So what that means is that, let's do it this way, the frictional force less a component of the weight force. What component? This component. Right? How do I calculate that component? Well, what I need to do to calculate this component is just multiply the weight by some fraction, right, essentially. Now, essentially what I have here is a geometry fraction. So let's figure out which side is which angle. This small angle here, where would it be? Would it be here at the bottom or at the top? It would be at the bottom, that's right. Because look, let's see, this line here is perpendicular to this line, and this line is perpendicular to this line. So if these two lines have an angle between them, then these two lines have that same angle between them. Another way of looking at this, if I extract a triangle, there's a right triangle like this. This side is the weight, it's the hypotenuse. And so essentially, since the angle's down here, let's see, the x side is this side, and the y side is this side. Okay? That's this side. So if I want to find out this fraction of the weight, then I'll need this side as well. How do I calculate the length of the hypotenuse? A squared plus B squared, that's right. So I need x squared plus 0.025 x quantity squared, and then square root, right? So factoring the x out, this is x root 1 plus 0.025 squared. Make sense? Technically the 1 is squared, but for our purposes it doesn't really matter. Okay? So in other words, whatever I have, let's see, on this side will be 0.025x, that's this component, divided by the hypotenuse, which is x root 1 plus 0.025 squared. X's go away as expected. That's the fraction I need to multiply by the weight, which is the mass of the vehicle times the acceleration of gravity. Okay. Anyway, that sum of forces is 0. Now, if somebody please plug this number into your calculator so we can just write a number down and not have that weird fraction to write over and over again. But essentially, what this tells us is that the frictional force that the vehicle is developing is equal to some fraction of mg. So I'll wait till you give me that number. So 0.025 divided by root of 1 plus the square of 0.025 square root.
.025.
Yeah, 0.025.
That's all I got.
That's the answer.
That's what I got too.
It's point
You have to take 1.
divided by 1.00031.
So it rounds off to 0.025 is what you're saying? I see.
It's
Okay.
0.0249.
Okay. 0.0249. Okay, thanks. Okay, yeah, I expected it to be close, but because this really doesn't add much to 1. Okay, and then that has to be multiplied by mg. Okay? So there's the frictional force that's developed by the vehicle. So once the vehicle gets up to, let's write this down here, 66 feet per second. Once the vehicle gets up to level ground, then what? Well, then there's no force trying to keep it from decelerating, and it will begin to accelerate, right? So the sum of the forces in the, let's say, x prime direction would simply be the frictional force, F. And that would be equal to the mass of the vehicle times the acceleration of the vehicle in the x prime direction. Okay. But we already know the frictional force that's developed. It's 0.0249 mg, and that's equal to max prime. Notice the mass goes away, so they didn't actually have to give us the mass of the vehicle. And therefore, the acceleration in the x prime direction is just 0.0249 times g. Did we need the 66 feet per second? Not at all. We haven't even used it. Okay. So somebody plug this in your calculator, give me a final number, and I'll make one more statement, we'll be done. So 0.0249 times g, where g is 32.2 feet per second squared. How much? 0.802 feet per second squared. So there's the acceleration. The reason they gave us the velocity is because you can actually calculate the power generated by the engine if you know the velocity and the mass of the vehicle. We're going to see this later in another chapter. But essentially the power being generated by the truck's engine is the force that's driving it forward times the velocity that it's moving at. So this force here is just the frictional force, which you see depends on the mass of the vehicle. The higher the mass of the vehicle, the higher the power output, which makes sense, right? All right, thank you guys for your attention and your patience. Have a good weekend. I'll see you next week.